Okay, this is the last section, 10.6, for application for growth and decay model. And if we look at here, we have a function to represent the growth and decay. Hopefully this reminds you of something that you have seen before. It's very similar to the continuous compounding interest. They say amount over time will equal to the original amounts e raised to a rate times the time. So the difference between this here is like the time for the exponential growth or decay may not be year, it could be months, it could be days, it could be weeks, it could be hours or seconds, depending on what the question tell you. Some of the book may write this formula like this: the amount over time equal to the original amount raised to the rate times time. So I'm gonna write in words. So amount over time equal to the original amount, and then you have your E, and then you will have the rate times whatever time that is. Okay, it has exponential growth and decay model. So it has two models. One of them is when the k, the rate is a positive number, then we will have a model look like this. It's going up over time. This is exponential growth. This is starting with the original amounts. If the rate k is a positive number, then it's going to grow over time like this. And then if we have this model is the decay model. So the amount when time is 0 starting here, and it's going to decrease over time. This is exponential decay, and then the k, the rate is less than 0, which is a negative number. So we will have two models. We're going to look at some examples together. We try to simplify this section because it's getting very close to the end of the semester. With this semester, we have to go online. So I'm just showing you 3 examples which are very similar to the homework you will see on my lab. So let's look at this. The first one is talking about present value. A company must pay $307,000 settlement in 3 years. So they want to know what amount must be deposited now at 6% compounded semi-annually to have enough money for the settlement. So we're going to do one lump sum of money, and this is going to be semi-annually. So it's compounding n times a year. So for that type of functions, we will use the regular compound interest formula, right? So A equal to P 1 plus R over N and T. And I know your textbook have a slightly different formula, so if you want to follow the formula, that would be alright also. The formula would be A equal to P 1 plus R over M, and then they have T M. Okay, but they represent the same thing. So looking at here, let's see, we have the amount over time is going to be $307,000 in 3 years, and then they want to know how much money you need to deposit. So P is something we need to find, and then it's at 6%, so R is 6%, which is 0.06, and N is semi-annually, which means twice a year, and time is 3 years, right? So we have all this information, and then we can try to plug it into the formula. So we started with $307,000 equal to, we don't know P, 1 plus 0.06 divided by 2 raised to 2 times a year for 3 years, right? So I'm solving for p, which we want to simplify this side, right? So let's try it. 307,000 equal to p. We have 0.06 divided by 2, which is 0.03 plus a 1, 1.03 raised to 6 power, right? So in order to solve for p, all I need to do is get rid of this part, right? And it's multiplying with p, so all I need to do is divide both sides with 1.03 raised to the 6 power both sides. So p will equal to, I'm going to need a calculator for that, 307,000 divided by 1.03 raised to the 6 power. Let's see. So my answer should be 257,107.67 if I round it. So which means that if I want to be able to have $307,000 to settle in 3 years at the 6% compounded semi-annually, I need to deposit this much money in the account to have enough money to settle. So this is part A for number 19. Part B say how much interest will be earned. So B is about interest. So we need to basically use my accumulated amount minus the principal, right? So what do we have? We have 307,000 subtracting what we just get, 257,107.67. If you use your calculator, it would be the interest is going to be 49,089,233. So let me double check. Minus 307,000, 49,089,892, sorry, 33 cents. So this is how much interest you're gonna make over 3 years. This is part B for number 19. Are you okay? Then the next part is C. So let's see C. For the C part, we say suppose the company can deposit only 200,000. So earlier we say they need 257, right? Thousand something, right? But the company don't have that much money. They only have $200,000. How much more will they need to have in 3 years? So okay. So C say, let's see, under the same condition, which is semi-annually 6%, 3 years compounding, right? So I'm going to need to use the same formula, 1 plus R over N and T. I'm sorry, I'm missing a P here. It was like something's missing. Or you use the book formula, 1 plus R over MTM. Okay, so if I use that formula, but in for the principal, I'm going to have only 200,000. The rest of the condition are the same. R is 0.06, N is 2, T is 3, right? So let's plug it in and see how much money I will get after 3 years. So for 200,000, 1 plus 0.06 divided by 2 raised to 2 times 3, right? So that would be 200,000, 1.03 raised to the 6th power, right? So let's see how much we are going to get. 200,000 multiply 1.03 raised to 6 power is going to be 238,810 and 46 cents. Okay, so that's how much I get after 3 years, but remember how much we need. So we use the need subtracted what we have, right? So we need 307,000 subtracting what we just found, 238,810.46. So subtract that on your calculator and see what you get. So it looked like we need $68,189, 54 cents more. So the questions say, this is for C part, need that much more. Alright, after 3 years. So instead of putting in enough deposits, if you only put in $200,000 in order to have enough money to settle, after 3 years you still need to another $68,189.54. Okay, all right, so that's C. The D part says, suppose the company can deposit $200,000 now in an account that pay interest continuously. So continuously, we use a different formula, right? We use the PERT, right? A equal to PERT. What interest rate would they need to accumulate the entire $307,000 in 3 years? So D, we're going to use A equal to PERT, PERT. And we have A equal to 307,000 and P is 200,000 and E is on your calculator, and R we don't know. T is going to be 3 years, right? So I don't think I have enough room here, so I'm going to put this down on a new piece of paper to solve that. Okay, so it started from 307,000 equal to 200,000. E, I don't know R, I know T is 3, right? So 307,000, 200,000, E, 3R, right? And we're solving for R, so the R side need to be simplified, right? So if we want to simplify the right hand side, we can divide both sides by, is it 200,000 or 307,000? So I want to simplify this side, so I divide both sides by 200,000. So the left side, 307,000 divided by 200,000 equal to 200,000 divided by 200,000. This would be 1, right? So this is just E, 3R. Okay, is it going to be a nice number? If it's a nice number, we can go ahead and write that, but if not, we will leave the fraction there because we don't want to round it until the very last step. 200,000. Okay. It looked like a pretty nice number, so we can go ahead and write that equal to E3R. So I cannot get both sides with the same base, and I need to somehow bring this down. So to bring unknown exponents down, I need to use the property of log, right? So I need to weight both sides with log, but instead of regular log base 10, because this has E, I will weight both sides with ln. Weight both sides with ln, because like remember we say ln E equal to 1, right? So they will eventually go away. So both sides have ln. And then we have 1.535. This is ln E 3r. So once you have ln here, the log property allow you to bring your exponents down, right? The power rule. So ln of 1.535 equal to 3r ln e. And remember we say ln e become 1, so sometimes people say cancel each other, but it's not really, it's equal to 1. So to solve for r, all I need to do is divide both sides with 3. So on the test, make sure you show me steps, okay? So and be very careful when you do this. When you do ln 1.535, make sure you close the parenthesis here, okay? Otherwise the thing will be incorrect. Divided by 3. So if you don't close it, it closes at 3, it would be the whole ln with that, so it's not quite the same thing. So that would equal to 0.142843 something, right? I pick up a few more decimal places because this is interest rate. So the rate of interest, I want to make it back to a percentage, so I move 2 decimal places, 14.28%. So if I put in $200,000 in this account compounded continuously, I need to look for somebody will pay 14.28% interest rate needed. Alright, so this is part D. This is the question for the first example. Alright, so if you're ready, we want to look at the second example. The second example is about the growth of bacteria. So this is similar to an homework question you were going to have. So for these questions, we have a culture containing 25,000 bacteria with the population increased exponentially. The culture contains 40,000 bacteria after 10 hours. So this is the initial amount, this is the amount after time, right? Write the function in the form of that. Give the number of bacteria after t hours. Okay. So number 25, we got the amount over time, like your book has weird formula. Okay, so let me write down what your book have. Your book have y equal to y0 ekt, right? So it means the amount over time equal to the original amount, e raised to the rate times t, right? So same thing. So the initial amount is 25,000, so I can put 25,000 here, equal to, after 10 hours over time is 40,000, and then we have E, K, and 10 hours, sorry, 10 hours would be 10 here for T, right? So we can solve for K, which is the rate, right? Okay, so to solve for k, we need to first divide both sides with 1. Because k is over here, so I need to make this side simplify. So divide both sides with 25,000. So 40,000 divided by 25,000 will equal to 1.6. So it's a nice number. I can go ahead and put it down, right? So 1.6 equal to e raised to 10k basically. So again, my unknown is up here. I need to raise both sides with ln. Normally just log, but because they come with e, we raise both sides with ln to bring down the unknown exponents, right? Okay. Alright, so both sides need an ln. 1.6 equal to ln e 10k, right? So once you have the log, the power can go down. So ln 1.6 equal to 10k ln e. What is ln e again? Ln e is just 1, right? So all I need to do to solve for k is divide both sides with 10. So be extra careful when you put that in your calculator. ln 1.6, don't forget what? Close the parenthesis before you divide it by the bottom part 10. So the k equal to 0.04700 something, right? So I can just say k is 0.047. Okay, and they want you to write this is A, right? So A part they want you to write as y equal to y0 ekt. So y equal to the initial amount was 25,000. E, my k value should be 0.047 t. So this is the functions you can use when they give you different amount for the t part. So this is the function they want you to write for this particular question. So this is the answer for A. All we did is we try to solve for k, the rate values. Okay, the B part, the book has really weird stuff. Okay, so B part say why the function from part A, so we got that in the form of this guy. So let me write that down. I don't know why they want it like that, but sure, we can do it. Y equal to y0 at. So this is very similar to this, except, so let me write down what we just got. We got y equal to 25,000 e 0.047 t. So that look like that, right? So your y0 is 25,000 and the t is here. It's the A part. So what's up with the A? So A is going to be this guy. So somehow you should multiply it together. I don't know why. So find my E, second ln to pick up the E, right? And plug in 0.047. And that's like the really long decimal number here, right? So we're going to do 3 decimal places. So again, I'm not sure what's the significance for this, but your book asked for it. You have a homework like that, so I want to show you an example. So all I replace is e raised to 0.047 is 1.048 here, and then you will raise it to t. Alright, so this is the answer for B. They want you to write in the form of this guy. Alright, one more, C. So the C part say, what does C say? So C say, how long will it take until there are 60,000 bacteria? How long mean they're trying to find T equal to what, right? That's how long. Will it take until they have 60,000 bacteria, which is over time, right? So that would be the y0, y either equal to the y value, or I like to call it the amount over time, right? So those are the given part they need you to find the t. Remember the function we found is here, right? So y equal to 25,000 e 0.047 t. So now I know my y is 60,000 and I don't know the time. Okay, so I can plug in my 60,000 equal to that, and then solve for t, right? Okay, so because t is on this side, I need to make my right hand side more simplified, so divide both sides with what? Divide both sides with 25,000. So 60,000 divided by 25,000 is what? 2.4, so it's kind of a nice number, so we can go ahead and write that down. 2.4 equal to e 0.047 t. So because I need to bring down my unknown exponent, so I need to raise both sides with ln, because this come with e, right? So ln on the left, ln on the right. So once you have ln, you can bring down the exponents, right? So go down here, ln of 2.4 equal to 0.047t ln e. Again, ln e will turn into just 1. So all you need to do now is divide both sides with 0.047, right? 0.047. But when you plug into the calculator, be extra careful. You're going to need your ln 2.4, don't forget to close the parenthesis, divided by 0.047. So that would give me t is about 18.6 hours. So this particular question is in hours. So after 18.6 hours, the bacteria will grow from 25,000 to 60,000. All right. So this is C part for number 25. Very last question on number 33. Okay. So they want to know the half-life of this. So this is some kind of radioactive material, I assume. So they give you the function here. Okay, so number 33. A of t equal to a of 0, e raised to negative 0.053 t. So I know it's decay model because it has a negative exponent, right? What do they mean by half-life? So it means if you started with 100 gram of something, then your amount over time would be half of that, right? So it's going to be 50. But they didn't specify how many, so you want to find the easiest number possible. So the easiest, I think, is like set this as 2 grams or something, and then half of 2 is going to be 1. So if I started with 2, I should end up with 1, right? But if I started with 100 and end with 50, still after you reduce it would be like 2 and 1, right? Okay, so E negative 0.053 t. So half-life means whatever your original is, just do half here. Okay, so first of all, to solve for t, I need to simplify this side, right? So divide both sides with 2. So this is 1 over 2 equal to 2 over 2, right? E negative 0.053 t. So basically 0.5 equal to 1 e negative 0.053 t, right? So again, I need to bring down my unknown exponents. So I need to raise both sides with ln, because this comes with e, right? So ln on the left, ln on the right. And this has 0.5, this is e negative 0.053 t. Once we have ln the log, we can apply the log property to bring down the exponents, right? So make sure you show all your steps on the test. Negative 0.053 t ln e. What is ln e? ln e is just 1. So all you need to do is divide both sides by negative 0.053, negative 0.053. So use your calculator very carefully. ln 0.5, don't forget to close the parenthesis, divided by negative 0.053. So this will give me, what are we looking for? T is about 13.08. This particular question is in years. So it takes like more than 13 years to get this to a of the radioactive material. Okay. Alright, that's the last part of 10.6.